Hello, statistics students. Here's a video for the binomial model. While the normal model applies to many real-life, continuous valued numerical variables, the binomial probability model is useful in many situations with discrete valued numerical variables. These come in the shape of counts or whole numbers like 1, 2, 3, 4. As we saw with the normal model, we'll do the same. We'll explain what this new probability model looks like and how to calculate probabilities with it. We will also provide examples and discuss why the binomial model is appropriate to the situations. The classic application of the binomial model is counting heads when flipping a coin. So we see these discrete values here. The flipping of the coin 10 times. Let's say I flip a coin 10 times. What is the probability that I would get one head? Or maybe we ask, what's the probability we get two heads? Or what's the probability that we get all 10 heads? This is a situation that the binomial model fits quite well, and the probabilities of these outcomes are given by the binomial model. Other applications of the binomial model: if we randomly select 10 people, what's the probability that exactly 5 of them will be Republicans? Or if we randomly select 100 students, what's the probability that 10 or fewer will be on the dean's list? These are all examples of situations where the binomial model applies. How do you recognize a binomial model? The first sign, like we've already said, that your random experiment is a candidate for the binomial model is that the outcome you're interested in is a count, discrete values. So for example, we said, what's the probability that when flipping a coin 10 times, we get at most 4 heads? So these are the counts. Flipping of the coin 10 times, and we get at most 4 heads. If the outcome you're interested in is a count, then all 4 of the following characteristics must be present to use the binomial model. Number 1, should have a fixed number of trials. We represent this number with the letter n. For example, if we flip a coin 10 times, then that's 10 trials, and n is 10. Number 2, only 2 outcomes are possible at each trial. We call these 2 outcomes success and failure. You can either be successful or you can have failure, one or the other. For example, we might consider the outcomes of heads to be the success, or we might be selecting people at random and counting the number of males. In this case, of the 2 outcomes, male and female, male might be considered a success. Number 3 condition, the probability of success is the same at each trial. We represent this probability with the letter P. For example, the probability of getting heads after a coin flip, we know this very well, is 0.5. It's a 50-50 shot, and it doesn't change from flip to flip. Number 4, last condition, the trials are independent. The outcome of one trial does not affect the outcome of any other trial. If all 4 of these characteristics are present, the binomial model applies, and you can easily find the probabilities by looking at the binomial probability distribution. And we'll achieve these probabilities by using the binomial probability distribution in StatCrunch. And I'll also show you how to do it by hand. So the key points: the binomial model provides probabilities for random experiments in which you're counting the number of successes that occur. Sometimes you can count the failures. 4 characteristics must be present. There are a number of trials, n. The only 2 outcomes are success and failure. You know the probability of success, p, and it's going to be the same at each trial. And number 4, the trials are independent. And this concludes this video on the introduction to the binomial model.